Um, Basically, this is the enumeration team working with the planning department, and I'm Sasamu Georgia, the enumeration forester, and this is Francis Kaikai, he is the enumeration officer, and we have John Y. Fufana here, the assistant enumeration officer, and Abdullah Dikanu, an assistant enumeration officer also. Basically, we are here to tell you the various operations we carried out in the planning department and how we carried out these operations. But first, we would like to explain to you the various equipment we use and how we calibrate them.
Okay, gentlemen, what are the instruments that you use and how do you use them? How do you calibrate them and all? Can you explain?
Okay, I think Francis will explain to viewers out there the various equipment we use and what we use them for and how do we calibrate them.
Well, these are the instruments we normally use on the field when conducting our enumeration activities. Like for this one, this is what we call the electronic caliper. The electronic caliper, which we will be using to capture all the dBH, and this one is the vertex. This one is the transponder. Both of this works together. This now is responsible to take the height and the ground distance. Then you have the diameter tape, which again will be used to measure the diameter of the tree. We have the 50 meters tape, which we normally use to calibrate the transponder and the vertex. So to start with the calibration, and we have the Bluetooth, which we use to connect with the caliper to take coordinates at the various points that we'll be moving. So to start with the caliper, really, in the morning hour before we start our job, we do normally calibrate these instruments because we want this instrument to be accurate before conducting any enumeration research. And the morning.
Put it off first.
Okay. So in the morning hour, before we start any activities, we have to calibrate these instruments to really see or know that this instrument is in good order for the activities, for the enumeration activity. So we first of all put the caliper on. After putting the caliper on, we then screw this button down, open the jar of the caliper, but you can see from the calibration instrument, you can see various numbers. You can see 10, 20, and 35. Each of these numbers really represents millimeters. Like for the 10, it represents 100 millimeters. For the 20, it represents 200 millimeters. For the 35, it represents 350 millimeters.
Wait.
To start this process, after you've engaged the calibration section of it, you then now open the jar of the caliper. You can see from here, it shows from the 10 section of it, it will now give you 100 millimeter. Then you come again to the 20, which will give you 200 millimeter. Then you come to the 35, which will give you now 350 millimeter. Then you screw up the calibration button. Now this instrument now is ready for use. Then for the other instruments, really, the transponder and the vertex, you first have to switch this transponder on with the vertex. like this, it will give you a beep sound. Now the transponder and the vertex is now connected to each other. Then you place the transponder on top of this pole. You place it here. But before that, really, we have to first of all determine where our 1.3 meter. We first of all have to determine where our 1.3 meters will be demarcated. So we find.
Continue.
We have to first of all. Yeah. We have to first of all determine where our 1.3 diameter at breast height. Yeah.
So we are 2.3 now. Okay.
Okay.
Where is the marker? Okay. All right. So go ahead. Okay.
So from where now we demarcate where our 1.3 stops, we easily now take this transponder and place it where the 1.3, we've already marked the 1.3. Then we'll use now the tape to take the 10 meters off. The 10 meters off.
Eh?
Okay, fine.
So you are 10 meters away from the transponder.
Yeah. So 10 meters away from it, and then you switch it on. Switching it on, you come to calibration. You've seen calibrate, and then okay, come. All right, so with this one now, all right, so you've seen.
You need to move a little bit.
Okay, so it beep with a 10 meters sound. Go again. So showing 10, it beeps. That tells you that it's accurate from 10 meter off, and this is 10. So it shows you it is in the correct working order. Okay, so we go.
After the calibration now, and after the calibration, I've already explained these are the instruments, and this is the way really we do normally calibrate them in the morning hour.
You have explained to us, you have shown us the instruments that you use and how you calibrate them in the morning. Would you please tell us now the operations that you carry out in your department?
Thank you very much. We carried out various operations like enumeration, tinning control, marking for tinning, ESP establishment, re-enumeration, survival counts, and pool selection for harvesting.
Okay, so let's start with enumeration. Would you please briefly explain to us how you carry it out and probably just show us how you'll be doing it?
Alright, okay. For enumeration, in the morning, if we have a compartment to work on, first what we have to do is to determine the number of plots that will be established in that particular compartment based on the area of the compartment. We have a sample method we normally use, and based on the number of plots, we try to select the areas this plot will be located. We do it randomly on the carry map. Like for example, we have this particular compartment which is AO2E. We are supposed to establish 12 plots here, and you can see from the carry map we've already demarcated the areas we're going to establish our plots. 12 of them, 1 2 3 4 5 6 7 8 9 10 11 12. And as you can see, the icon is already in one particular plot, which is here. So it tells us that we are going to establish the first plot in this particular area. Now, after that, since we've reached this particular location, we put the stand here and place the transponder on it. And now we do have take the caliper. You can come closer to see. We're actually doing stock take now. Or let me start so you return. Okay, now switching it on, go to stock take and you go to measure. Is this one on? Now it tells you batch 1. Is there any information in batch 1? Yeah, okay. Now there is no information in batch 3, so we go to batch 3. Now you click on this black button at the back here. It goes to version. The version is 2.6, of course, and the management unit is 240. And you go to compartment. You enter the compartment you're working on. This is AO2. AO2E. There you enter. Species, we don't enter that one. The stand area for this particular compartment is 5.9. You enter 5.9. Sorry. 5.9. You press enter. Now you go to the type, a stock take, of course, and the plot is going to be circular, and the dimension we normally use is 9.77. So you enter all this information, take the, it also asks you for the coordinate of this plot. You enter all these ones and then you set for the operation. Now you start with the first 3. The first, what we have to do is to determine the number of trees that fall within the plot. So based on this center of the plot, we take the radius, which is 9.77. So we use the vertex to do that one. So it tells you that this particular tree is in the plot. So it goes down. Okay. Now this gives us 6.87. So it tells us it's within radius. So meaning this particular tree is within the plot. So we do that for this is 9.21 and it's within radius because we are looking at 9.77. So same thing. After knowing all the trees that fall within the plot, we now start our measurement. We go clockwise. So coming to the first tree, we take the measurement at 1.3, and if you look at my breast height here and the caliper, they are almost at the same place. So that's where we normally take the measurement. So we do that for all the tree. As you enter it into the tree, you click the black button, it stores into the system. So you go to the next tree. Of course.
So for diameter, you measure all the trees in the plot.
All the trees in the plot. We do that
Okay.
for all. So we enter. As you go, you enter. So we do that for all the trees that fall within the plot. At breast height 1.3. Okay. Okay, so after now we'll take the DBH of all the trees that fall within the plot. The next thing is to take the height pairs. The height pairs is going to base on 3 classes. We're looking at 3 classes of the trees that fall within the plot. One, we're looking at the smaller size, the medium, and the big. So we start with anyone. We can see that this one is, of course, the big class. This is like 21.4. So we place the transponder here, and then we move some meters off. We move some meters off a distance that you can be able to see the tip of the tree. Of course, at this point I can be able to see the tip of the tree clearly. Now, when it connects, it gives a beep sound. Then you look at the height. We normally take 3 different readings to see if there's consistency in the height. Now, we can see from the reading I got 25.9, 26.1, 25.8. So like the differences are not much great. So you can even redo it to have something good. Now, okay, so now I have 26.1, 26.1, 25.8. So we'll decide that the height is 26.1 because that is what is consistent. So we do that for 6 of the trees that fall within the plot of different class, like I said. After doing that, we move to the next plot. Okay, this is how we carried out the enumeration. And after doing this, we try to demarcate the plot so that if anybody comes, maybe want to do some verification, they will be able to identify that this is where they establish it. Now, based on the center of the plot, which is here, we place a stick. We look for a stick, place it there, and we tied a caution tape on it. We tied a caution tape on it. Right. And also, closer to the point, we tied a caution tape to the tree that stands to it and write on it that this is plot 1 and tree number 1. Just try this and that way. Why we normally do this is for the person to know that this is the center of the plot. So if maybe he comes and wants to do verification, you will know that this is the center. This is where I'm going to place my stand and take the radius to know that these are the trees that fall within the plot to verify. And on this tree, which is very closer to the plot, we also tied and write tree number 1 plus 1. So this is P1. it tells you that in this particular compartment, this is plot 1. So basically, this is how we carried out enumeration.
Thank you so much.
You're welcome. I'm James Pesia, supervisor for marking for team. I'm presently in compartment A02E, and we are about to do a mark of 300, which is a mark of 12. But presently, when we come to a particular compartment, we try to do an extraction line. Wherein an extraction line is where we have easy access into the compartment. Wherein the bed loggers, the tractors can have easy access into the compartment to get the logs out to the required site. And presently, we do a count of 20 lines. As you can see, the straight line, we count from 1 to 19. Making 20, that's where we're going to pull the extraction lines. We do that all through the whole compartment so that we can have easy access for our bed loggers and tractors into the compartment. Yeah, after we finish our extraction lines, we now establish our plot. As you can see, guys, we are establishing a plot now. We use the 3-4-5 method wherein to get a perfect straight line for our plot. And each plot in each hectare is comprised, we have 25 plots that make up a hectare. So we establish our plots using the 3-4-5 method so that you can get a perfect straight line. As you can see, the guys are establishing the plot now.
Wait.
Okay.
Go now.
We are using a line measured 20 meters to establish our plot. Our plot is measured 20 by 20 meters. It is square plot. So we use a line being measured 20 meters to establish the plot all over the compartment. As you can see, this is another peg here. We have established another 20 meters over there. We are going to establish another peg over there. After we have established the plot, we are going to count the number of trees within that particular plot. Presently, we are doing a mark of 300, which is 12 trees to be remain in each plot. So we are going to count the number of trees within this particular plot, and then we are going to remove the excess. As you can see, the man is counting the number of trees within this particular plot now. We don't just remove the excess. We have criteria that we look for, like the double leaders, the broken top, the windfall trees, disease affected trees. We remove them. As you can see, the man is counting now to get the total number within this particular plot.
27 no double leader. About 27 no double leader.
Okay.
Now the man has finished counting, and we have 27 trees, standing trees in this plot. So we are going to remove 15, and we have criteria for removing these 15 trees. We look for the double leaders, the broken tops, the windfall trees, disease affected trees. That's how we are going to. The bad ones, like the fork trees, we are going to remove them. All the bad trees within this particular plot, we are going to remove them. Leave only 12 trees in this plot because we are doing mark of 300, which is 12 trees per plot.
Okay, we go.
How much you don't put? How much you don't put? 10. Now 5 more to go. I think this one should go. You might just say, so you want to say, so based on this criteria, this is how we carry out the marking process. Presently, we have marked 15 trees in this particular plot, and we have left 12 trees remain in this particular plot because we are doing mark off which is 12 trees per plot. Thank you very much.
Yeah, thank you.
Now, can you explain to us how and why you do thinning control?
Okay, thank you very much. For thinning control, basically we do it to actually know the volume of trees that will be taken out and the volume that will remain in a particular compartment. And it is normally carried out after they've marked a particular compartment. Now, for example, this compartment has been marked. Now we come to the compartment, we establish our plot in the plot we've already established for marking, which is the 20 by 20 meter plot, so 400. It's basically the same process as the normal enumeration. We determine the area the plot will be established randomly in the office, like I showed you in the enumeration. Now, for example, we come to this particular plot, which starts here, there, and there. Now, in this particular plot, you first switch on your caliper. You can see you have thinning control here. You go to thinning control, you go to measurement, and then you enter all this information then. And then you're set for work. You take the DBH measurement of all the trees that fall within this particular plot, and you ensure that you tag the marked trees. Why tagging the marked trees? To give an illustration that yes, this tree is being marked to be taken out. So if you're analyzing the data, you know that all the trees that have been tagged with 1, they are the volume that will be taken out, and those that have been tagged with 1, these are the volume that will remain. So you try to analyze your data to determine the volume that will be taken out and the volume that is going to remain in the plot. And like I said, basically it's the same process as the normal enumeration. We also take 6 height pairs within the plot from all the 3 classes, the small, medium, and big. So basically that's the process. Okay, so now this is how we tag. You can see tag here. Since this is being marked, you go to 1 and enter it. Then you take the DBH and put it. Now you go to the next one. This here is not being tagged, so there's no need to go to 1. You still leave it as 0. You just take the DBH measurement. Then 1, you enter it and then take the DBH measurement. So basically this is how we do for all the trees.
Okay.
So basically, this is how we do the thinning control, similar to enumeration, but the only difference is here we tag trees based on the marking done, and we work in the established plot that has been established already by the marking 14 and 18. So that's it. Thank you. All right. Okay. Now we may like to know about the PSP. First, why do you establish PSPs?
Yeah, well, we do normally establish PSP because we want to build a growth model to determine whether our compartment is doing great or not. Either the compartment is increasing, the trees are increasing in their diameter or their height or not. That is what really is the essence of establishing this permanent sample plots.
All right. Okay. Now, how do you go about the selection of this site for establishing PSPs?
Okay. Now, PSP, we have three criteria really in establishing these PSPs. One, the site index. We have to think about the species. We have to think about the topography. How really the topography is really determines whether are we to establish more than one or two PSP within a compartment. Like for compartments that are above 35 hectares, we do normally establish 3 PSPs. Why? Because we want to see the phases, the topography phases of all that are represented. We first have to establish one at the top, one at the middle, then one at the bottom. Why? Because we want to compare these 3 sites, these 3 plots, to really determine these 3 plots are now going to be represented. So we can really know whether these 3 areas or these 3 PSP within this compartment is doing great or not. So the 3 plots now will be used to analyze the data of the PSPs.
All right. Okay. Now, how do you establish these PSPs?
Well, in establishing these PSPs, we use the 30 meters by 30 meters. This is the dimension mostly we use. The 30 meters by 30 meters, which is 900 meters square. This is really the dimension mostly we use. Within that 900 meters square, we are going to enumerate each and every trees and their parameters really. We look at the way how the trees swap. We look at the biotic and the abiotic factors within the compartment, like either the tree has termites or not. We look at all the pictures really, because we also really see or know how really this particular tree is growing, what is its effects, and what is really disturbing the tree not to has its proper diameter or height. So that is really the procedure normally we take in enumerating this PSPs.
Okay, now you take the measurement.
Yeah.
Measurement of what? DBH?
Yeah. Like for example,
Go.
well, in that area, we first after we've established the PSPs, we are going to demarcate where our 1.3 stops. So in the next enumeration, when we are about to re-enumerate it again, we exactly re-enumerate it at where we already ringed our 1.3. So in doing that, we want to avoid having wrong data or wrong reading. That is why we normally ring this section of it. In doing that, every year we do our follow-up through that and take the height of the tree to determine the volume or the increments, whether the compartment is doing great or not. So that is how really we do normally do our enumeration on PSPs.
Okay. So how do you go about with the data? How do you go about the analysis of it?
Well, like in analyzing the data,
we use the ODK, which is the open data kit, to input all the informations, all the parameters within this ODK. Now from the ODK, we now transfer this information into the MIRO Forestry, a system that is built to analyze this data. So this is how really we do normally analyze the PSP data.
All right. Okay.
Okay. So basically, this is how we do normally conduct our PSP enumeration.
Okay, so you normally do re-enumeration or re-measurement of these PSPs when it is normally done.
Yeah, we normally re-enumerate PSPs based on the year. If we establish the PSP on the 1st of January, next year on the 1st of January, we are going to re-enumerate it. It's a yearly process, really. It's a yearly activities that we normally undertake.
All right, okay. All right, thank you very much.
You're welcome.
Now, Mr. Kaikai, can you explain to us how you drew survival count?
Yes, sir. Well, survival accounts mostly, we normally conduct survival account during the rainy season, which is the planting season, really. We have two types of survival accounts which we normally do during this season. We have the first survival and the second survival account. Really, during survival accounts, we really want to, what is our aim really? We want to really know the mortality rates within this compartment within 2 weeks after plant and 2 months after the planting season. We want to check the mortality rate. But before going to the field to do the survival account, really, we have some calculation which determines the amount of plots that we are going to establish within that compartment. For survival, we normally take like 5%, 7%, depending on the area of the compartments, really. For example, if you want to take like 5%, 5% upon 100, which will give you now 0.05, multiply now by the effective area, then you multiply it by 10,000. You divide it by 1080. Why 1080? Because the dimension that they are using, the enspace dimension currently the Comlink is using is 3.0 by 3.6. So if you multiply this 30 by 36, it will give you now 1080. Then through that, you will do your calculation, then you exactly know the amount of plots that you have to establish within the compartment. How the survivor go? We use the 50 diameter tape to determine the length and the width. The length and the width now depends on the 10 rip line and 10 plants. 10 rip line by 10 plants. That is how we determine our length and width. Within that rectangular plot that we've established, we then now have to count each and every tree that is found within this plot. We even record the one that is not even found, the dead, or even if there is a hole that they left out during the planting season, we record all that in the ODK, which is the open data kit. So this is how normally we conduct our survival accounts.
Okay, thank you, Mr. Kaikai. That was a good explanation. Thank you so much.